Hey, this is Mr. H. Hey, in my last video, I did one question, and I did it using the quadratic formula, and then I did it again using I solved it using completing the square because I wanted you guys to see that both of those techniques will get you to the same answer. But what I wanted to show you in this video is that basically the way that we came up with the quadratic formula is by this happened thousands of years ago. They basically completed the square using the generic quadratic equation. So what I'm going to do is I'm going to go back and kind of explain the how we get to the quadratic formula by completing the square and how that formula came into being. Um, so in my prior video, one of the things that I said that is that in order to use completing the square, you have to have one square. And right now we have a times x squared. So one of the first things that we have to do is we have to divide by the leading coefficient. So we're going to divide everything in this quadratic equation by a. And when we do that, we're going to have 1x squared plus b over a x plus c over a equals 0. Now we can go. And what this means is that we have one square with sides of x. We have one rectangle with a side of x and a side of b over a. So we multiply those two together to get the area b over a times x, right? So now we're almost ready to start completing the square. One of the first things I want to do, and I think is good, is take the constant, the c over a term, and move it to the other side. And the way that I'm going to do that is I'm just going to subtract c. Come on. I'm going to subtract c over a from both sides. So I'm going to have c over a on this side. Now, that means it's gone from over here. We don't have to worry about it anymore. Now all I have to focus on is completing the square. Now, from my prior videos, I showed you the process of completing the square. So basically, you're going to take this rectangle and you're going to split it in half, and you're going to add one half of the rectangle here. And then you're going to take before we do that, and we know since we're taking half that the length of this is going to be, I want this to be red. I want this to be b over 2a. So that's how you split that side in half. If it was b over a, now it's going to be b over 2a. And the same thing, I'm going to take this other side, I'm going to flip it, and then I'm going to try to put it right here on the other side of the square. And again, this side is going to be b over 2a because that's the length. Now, all we have to do from here is we have to figure out what is this little square going to be. Well, it's going to be b times 2a times b times 2a, because that's this length, and this side is b over 2a. So we need to figure out what this is. So this is going to be b squared over 4a squared. So that's this little piece in here. So I'm going to try to write that. Now, so in order to complete the square, we had to add that b squared over 4a squared. So that means we got to add that to both sides. So I'm going to add b squared over 4a squared. And then I also have to add it to this side, b squared over 4a squared. Now, I'm going to do a little bit of kind of rearrangement. One of the things we know is that we now have this new side, which is x plus b over 2a, and all we have to do is we're going to do this. It's going to be x plus b over 2a, and then we're going to multiply those two sides together to get the new area. So we know we're going to have this. Now, I'm going to do a little bit of algebra over here. I'm going to rearrange these. So I'm going to put this as b squared over 4a squared first, and then I'm going to do minus c over a. Now, if you remember from third or fourth grade, in order to combine fractions, subtract fractions, you have to have the same denominator. So that means that I have to multiply this by 4a and the top by 4a, right? So, and then I'm going to have b squared over 4a squared minus 4ac, that's what we have on top. And on the bottom, we're just going to have 4a squared. Now we have the same denominator, so we can write this, we can combine it by saying b squared minus 4ac over 4a squared. Now we're almost done. Remember, once we know once we get this, once we get the completed square this way, and now we have the other part here, we can take the square root of both sides. So let's do that. I'm going to take the square root of this side, and I'm going to take the square root of this. So on this side, we're just going to have, since they're inverses, it's just going to be x plus b over 2a. And then on this side, it's going to be plus or minus, and we're going to have, I'm going to do these in two parts. This is going to be b squared minus 4ac on top. And then if I take the square root of the 4a squared part, because this is a perfect square. So look, remember, if I take the square root of, the denominator, basically what I have is 2 times a, and I can pull out, just like we've been doing to simplify, I can pull out a 2, and I can pull out it, and I can pull out an a, and then there's nothing left inside. So this part here just becomes 2a. Now, the last step is I am going to subtract a negative b over 2a from the left-hand side of the equation, and I'm also going to subtract b over 2a from the right side of the equation. And so what I'm going to have is this, b squared minus 4ac over 2a. These cancel out on this side. So I'm just left with x. And then we can combine this because they have the same fraction or denominator. So I'm just going to extend this line. So there we go. We have solved for the quadratic formula. So what we have is x equals a negative b. By the way, sorry, a little sloppy. Once we combine them, we only need 1, 2a down there because they have the same denominator. So it's going to be a negative b plus or minus the square root of b squared minus 4ac over 2a. And that is the quadratic formula. And that's how thousands of years ago, someone who was very good with algebra and very insightful was able to solve for any quadratic. So they generalized this. And now instead of having to do this, completing the square every single time, we can just use this formula once we know the a, the b, and the c. But it also means that we have to make sure that the quadratic formula is equal to 0. So once you've got those conditions, it doesn't matter. Once you find the a, b, and c, you can just plug them in. So now, even though we teach completing the square, the quadratic formula is quicker. Once you know the a, b, and c, plug them in, boom, use the formula, it's done. Completing the square, it's a good practice because you should know how to do this. It's good to know how to do this, but we have the quadratic formula. So I hope this has been insightful because when I first started doing this, I didn't see the connection or it wasn't as strong, but now it's clear to me exactly how we got the quadratic formula. So I'm going to stop this and I'm going to post. And if you like it, give it a thumbs up.